So, Senator Rennick.
Hi guys, how are you going? Given that heat's kinetic energy, the energy of motion, is it fair to say that CO2 traps heat, or is it fair to say that climate change theory invalidates the Stefan-Boltzmann law that says radiation is emitted in all directions?
Senator, are we sticking with classical physics, or did you want to go to quantum as well?
Yeah, no, classical.
Oh, classical. So, yes, Senator. So in classical physics, gases like CO2 and water itself in the atmosphere absorb energy from the sun, and they heat the surface of the Earth.
Sure.
From memory, and it's a few years since high school, since uni physics, but from memory, the Earth is about 16 degrees hotter as a result of all of the gases in the atmosphere.
Okay,
and that's been good for us so far.
Question I noticed last time, and I was told that was hypothetical, that couldn't be answered. Yeah.
Just from a point of view of optical physics, that's the heat exchange, Senator.
Yeah. So it also radiates though too, doesn't it? It doesn't just absorb, it radiates?
It depends, but it depends, Senator. Sometimes,
or conduction. So it loses it either via conduction or radiation or convection. Yeah, three forms of heat transfer. Yep.
So generally speaking, the atmosphere is kind of like a protective blanket around the Earth that holds the heat in, and that's what made us all a bit warmer than we otherwise would be without the atmosphere.
That's true. Yep. But it's also, you've also got convection, don't you?
Of course, so the air currents circulate and the heat moves around.
But so just so we're clear though, that heat does radiate as well as absorb.
Yes, Senator, and that's also, this is where you're talking about the Boltzmann constant. Yeah.
So that's correct, it does radiate heat as well?
Yes, Senator.
Yeah. And where does radiation and heat come from, the energy from radiation come from in the first instance?
Well, when light impinges on a surface, that's why I asked about whether it's classical or quantum. So if the sunlight hits a surface of an object, it'll either be reflected or absorbed.
Okay, yeah, I understand that. I said, where does it come from initially?
The absorption of a photon of energy. So this is the quantum thing.
So the creation of energy, where does it happen? I'll give you a clue. Where does it happen in the solar system?
In the sun.
Yeah, exactly. Yeah, okay.
Which is really hydrogen energy. Yeah.
Yes, exactly. So the energy initially comes from the fusion of hydrogen and helium, as per E equals mc squared.
Exactly.
Yep, thank you. So is it therefore fair to say that the amount of energy in the atmosphere is first and foremost determined by the output of the sun?
The amount of energy in the atmosphere?
In the first instance.
Well, Senator
Rennick, look, I'll allow you to go a little bit, but I mean, this is estimates hearings. It's about the expenditure of public funds.
Exactly, and we're spending, spending a lot of money here on theories that need to be tested on science.
It's not. I do not believe the estimates hearings are a discussion forum for scientific thought.
Yep.
We've really got to get to something that's related to the expenditure of public funds.
Well,
I'll give you some, Senator Rennick, I'll give you some latitude, but we do need to get somewhere close to the expenditure of public funds.
Sure, I am getting there.
Okay.
Okay. So, so is it fair to say then that CO2, when it absorbs heat, it's got 4 vibrational frequencies, 2.8, 4.3, and 2 degenerate modes at around 15 microns, and according to Wien's law that the major peak radiation around that level would be about 192 degrees Kelvin, or minus 80 degrees for radiation. I'm not talking about conduction or convection here.
So, Senator, in general, molecules like CO2 tend to absorb more in the infrared than they do in the visible or the ultraviolet.
Yes, that's what I've just said.
And that's what you're saying, yes.
Yeah. Yeah, so, but there's also, when they absorb at the infrared, they generally have a peak emissivity at a certain temperature, according to Wien's law. Are you familiar with that?
Yes, Senator.
Yeah, okay. So, just wanted to clarify that, because where that emits up at the top of the atmosphere, so minus 80 degrees is a long way up in the atmosphere. Yep, you're a bit... Okay, it's fine, you don't have to answer it. Don't have to answer it. Okay, so I guess... Where I'm getting to is, effectively, we have 3 forms of heat transfer: radiation, convection, conduction. The main form of heat transfer in the atmosphere after radiation comes down and heats the Earth is convection. Yep.
Well, you have a bit of both, actually, Senator, and because the air moves and heat can transfer through the physical movement of the air molecules or through re-radiation of the light.
Yep.
And that's the quantum part of the effect, where a photon's absorbed and then it can be re-emitted, sometimes at a different wavelength.
Sure. Yeah, but I guess my point is radiation heats, convection will cool. Like, so you've got evaporative cooling, you've got thermal currents, you have clouds. You have a number of mechanisms that will cool the atmosphere as well as heat the atmosphere.
So you have a flow of heat in and a flow of heat out.
Yeah, that's right. And the second law of thermodynamics says that the entropy of the system will increase. So effectively, you know, if you've got a lower atmosphere with say it gets 3 degrees hotter, as per one of the IPCC forecasts, then in theory, if you assume that, you know, use the first law of thermodynamics, that the energy of the system, overall system won't change, it would have to be 3 degrees cooler in a higher part of the atmosphere, then surely if you apply the second law of thermodynamics, that basically the atmosphere is eventually going to even out in terms of temperature, won't it? Because hot air does rise.
So, Senator, if I follow your logic, so what do we know? We know that over a very long period of time, the temperature of the Earth has increased a little bit, about 16 degrees, as a result of the absorption of radiation in the atmosphere by everything, CO2, water vapour, the whole 9 yards, our breath. And that's an equilibrium situation. And then we know that if we change that equilibrium, if we put something else in the atmosphere that increases the absorption, then we'll see a continued increase in temperature.
Yep, totally agree with that.
Because we know we've seen it before.
Yep, no dramas. But the question is, so greenhouse gases make up about 5% of the atmosphere. You've got nitrogen and oxygen, which makes up the other 95%. But they also play a role in convection. So when you say there's a blanket around the Earth, I think that's a poor characterisation, because, you know, I would describe it as if you're sitting in a car with the windows wound up, you're locking out your convection, right? But the reality is, in a greenhouse you mightn't have convection, but in the atmosphere you do. So if you wind those windows down, or you come home in the evening and your house is hot, and you open up the windows, the wind will blow in and convection will often even out the temperature, not perfectly, but, you know, so you've got similar. So I guess my point is that many of these models underestimate the impact of convection, don't they?
But remember, it's a closed system, Senator, so if I use your analogy of the car, we'd have to vent atmosphere into space in order to get that change of mass. Sure. Because energy mass equivalence, again, quantum theory, but we don't do that. The atmosphere is pretty much trapped, and that's kind of why you have the greenhouse effect.
But we have hydrogen that escape into the exosphere and things like that. And I'd also argue that at the equator, you've got, your troposphere is, 16 kilometres high, whereas at the poles it's 10 kilometres high. So that hotter air does expand and pushes out anyway, right? So the idea that it's a confined space, because heat's basically a function of volume, okay, I can also argue with that, because the equator has a higher point of the troposphere, and I would argue the proof of that is in your dry adiabatic lapse rate, whereby it's the same at the equator as it is at the poles, despite the fact that there's much higher concentration of CO2 at the equator.
What's the hell at the moon? Can he do it on someone else's time? Like, you've given him a warning. This is ridiculous. This is just ridiculous.
No, this is very important. Hang on, we're spending over $20 billion in subsidies for renewables. So
let's try to be respectful.
I'm almost there.
However, Senator Rennick, we have got nowhere near the expenditure of public funds as yet. I'm conscious of the time.
Okay.
So, Senator, I'd be worried if we were expending much atmosphere, if we were venting much atmosphere into space, because that wouldn't be a very sustainable situation. So I don't know that there can be a significant mass transfer.
But space. Yeah, I'm not saying the atmosphere goes into space. But anyway, so let's get to the cost gen report, right? So basically your guys have come up with a discussion paper on cost gen. They've made a number of assumptions. One of them is that coal-powered fire stations last for 30 years. Now, we've got one at Gladstone, which is, been around since 1976 or 78, so it's 42 years going on to 50. Why is it that the CSIRO has assumed that coal-powered fire stations only last for 30 years when it's well known that, they last for over 50 years?
I know that power station. That's the one that powers the smelter at Boyne Island.
That's exactly right.
I know that one well, yeah. Senator, I'll let Dr Mayfield answer that, but when I read the GenCost report, I guess what I read was a little bit different, and that the coal-fired power stations that Australia already has will naturally be retired, regardless of anything else, regardless of any policy, will naturally be retired for economic reasons by about 2040. just as they reach the end of life.
Yep.
And so the question we were trying to answer after talking to the power companies was, if that's true, what will you build? What will you build next? What do you need to build now, so that Australians can get a lower cost of electricity in the future than we have now?
Yep.
And that was really the purpose of that. But I'll let Dr. Mayfield.
Senator, so Peter Mayfield, Executive Director for Environment and Energy Resources.
Sure.
So I think, as per our conversation we had back in February with Paul Graham and myself, with respect to the power stations' lives, so they definitely have a technical life of 50 years and possibly longer. The context of the work that was being done was looking at what was the economic pathways forward for a range of different technologies for AEMO. And the work looked at what was the economic life of the plant as well, given the changing conditions in the national system. And that's where the 30 years comes from, given the different financing arrangements that are required.
Well, that's interesting, because the Finkel report said Kogan Creek, for example, only cost $9 a megawatt for operational costs. I mean, that's a mine-mouth coal mine power station that's owned by the Queensland people, so it's not subject to market forces or anything like that. There's 400 million tonnes of coal there. It's a brownfield site with a second pad already built. I find it difficult to believe that you could assume that was going to cost $2.80 a gigawatt, a gigajoule, sorry. So I do dispute your assumptions there, but I'll just finish off with one other question. Sorry, I'll just get the points here. So Professor Richard Harrington, head of Earth Sciences from the Natural History Museum of London, has said for the UK to meet its UK electric car targets of 2050, they would need to produce just under 2 times the total annual world cobalt production, nearly the entire world production of neodymium, 3/4 of the world lithium production, and at least half of the world's copper production. Now, that's a hell of a lot of energy that's going to be required for batteries that mightn't last more than a decade for just one country, isn't it?
Yeah, and we're worried about batteries too, Senator, because they cost about 3 times more to recycle the lithium batteries than the actual value of the materials. So we're very worried about that. It's kind of one of the reasons we leaned hard on hydrogen, because we think hydrogen is actually a very attractive energy storage mechanism, and actually Australia could control that and actually build it here, rather than relying on rare earth metals that are coming from China or other countries.
Yeah, and lithium's a 1% ore body as well. Did you know that? So you've got to mine 100 tonnes of it just to get one.
Yeah, and it's a very environmentally unfriendly material to process, which is why we don't really process it here in this country. But if we could and do it cleanly, that'd be another interesting option for Australia.
Sure.
Just in general, I think we need to add more value to our raw materials here.
Oh, I totally agree.
We'll get more value, more jobs here.
Yeah. Okay then, thanks very much for your time.
Thanks, Senator.
Appreciate it.
Thank you.